Last time I lectured, we left off on types of quantitative graphs. One of them was a histogram. There are different types of histogram, which we'll go over today. First type is a unimodal. By modal, or models, modes, I mean peaks. Do you see peaks in your graph? Unimodal means you have how many peaks? Uni means one. I have one peak, as you see here. Examples are earthquakes. It's all quiet. All of a sudden it increases in intensity and magnitude, and then it goes down again. So an earthquake is a type of unimodal data. So if one peak is unimodal, what do you think is two peaks? Very good. Bimodal. A histogram with two peaks, as you see here. Think your test. Some people did not study at all, and they bombed it. And then the other group studied, and they aced it. There was not many people in the C range, which may have happened. It's happened sometimes, I've seen. So you either studied on this side, or you didn't. That could be an example of bimodal. Multimodal is three or more peaks. What kind of example do you think would give this? Actually, you know a good example was COVID. Remember, you had to either have a 69, 79, 89. There was nothing in between. So that would probably be an example of a multimodal. Uniform means there's not much there to tell you about the graph. A histogram that doesn't appear to have any obvious mode. Do you see any peaks here? Everybody pretty much did about the average, right? Everybody pretty much was on the same line. That's unimodal. You don't see any significance. Symmetric. So with our unimodal graph, it could be said, you could say it's symmetrical. So if I were to take this graph, fold it down the middle, and fold it over, I know it's not perfect symmetry as you see in like algebra, but do you kind of see a somewhat slight symmetry to it? Yeah. This would be considered symmetric. Would this be considered symmetric? Yeah. A uniform will be considered symmetric. What about multimodal? Usually not with multimodal. It's possible, right? If you have an equal number of peaks on this side and this side. What about bimodal? Could it be symmetrical? It could sometimes. This kind of looks symmetrical, right? If I put it down the middle and fold it in half, you either failed or you passed. And unimodal is usually symmetrical. Usually. Except for when we get into what's called skewed. You can either be skewed on the left or skewed on the right. Notice the skewed is referring to the tail. This is left skewed, so I have a tail on the left side. It's not talking about the greater values being skewed. You want to call this right skewed because you see more stuff on the right. You would call it left skewed because you see less stuff on the left. So here's an example of left skewed. Right skewed, where's my small amount of data? It's on the right. My tail is on the right. Would you say this is symmetrical? No, not even close. And then there's outliers. Data that stands off away from the body of the distribution. So notice I have a what kind of histogram would you call this? Unimodal, right? Also symmetrical. Except for the fact that I have a outlier. This little piece of data way out here. So this is referring to, I believe, age. So 42 to 60. There was no people in the 62 to 70 range, and out of nowhere there was a 72-year-old guy. That's something to say, hey, maybe I should find more people within this range and collect data. Describe the distribution. What do you see? What kind of mode? Unimodal? What else can you say? Symmetrical? Do we see any outliers? No? No outliers? That's about it. That's what I see. Looking at this one, 1,000 students from a local university were sampled to gather information such as gender, high school GPA, college GPA, and a total SAT score. The results were used to create histograms displaying high school grade point averages for both males and females. Describe the distribution of females. So up here, see M, I have males, and down here, females. What does it look like though? Do you see any tails? Does it kind of look like it's tailing off to one side and greater values are on another side? So what kind of skewed? Skewed to the left. Think the tails, right? When we're talking about skewed, we're talking about the tail. Where's the tail? The tail's on the left. Right skewed, tail's on the right. Yeah, I know it's kind of, I think of where the data is. So I would say it's a little bit skewed to the left. I would say the majority of my information is that females are between what GPA? Like, think of the average. We're going to talk about averages tomorrow, the mean. What would you say is the average GPA for females? Just ballpark it. 3? Oops. Like right here? Give or take? Yeah, we don't know how this might affect all this out here. Maybe somewhere between 3 and 3.1, 3.2. Somewhere around here. We'll see that tomorrow. But for today, we're just describing the graphs.